Hello, in this unit we are going to deal with complex numbers. The objectives we would like to have at the end of this unit would be to have defined complex numbers and the sum of complex numbers. The requirements are actually quite few. It's just to know the real numbers and to know how to operate with real numbers in a basic way from what you see in high school. Well, let's start with the definition. Suppose we have two real numbers that we are going to call a and b. Well, we call the complex number in binomial form the expression a plus b times I. The question would be, but what is I? Actually, I is what we call the imaginary number that takes the root value of -1. That is, that verifies that I squared is equal to -1. A complex number will normally be represented by the letter z and the set of all complex numbers by the capital letter C. Given a complex number, we call the real part, in this case the part of A, and the number b will be called the imaginary part, which is multiplied by the imaginary number I. Complex numbers are, for example, 2 plus 3i, 0 plus 1 times I. Normally, when I is multiplied by 1, we don't write it. So the 0 plus I would remain exactly as I, the imaginary number. Another example of a complex number would be 2 plus 0i. In this case, the imaginary part would be 0. Another example, for example, would be -1 minus 8 times I. Now let's review the real part and the imaginary part. In the first example, as we see, the real part is 2, and the imaginary part would be 3. In the second example, the real part is 0, and the imaginary part is 1. That is, as I said before, it would simply give us the imaginary number I. The next 2 plus 0i, the real part is 0, but the imaginary part does not exist in this case. And finally, in the last complex, -1 minus 8, the real part would be -1, and the imaginary part -8. Well, let's see what happens in each case. If the real part is 0, but the imaginary part is not, what we have is what we call a pure imaginary number. On the other hand, if the imaginary part is 0, but the real part is not, then what we have is a real number. That is, we can somehow consider that the real numbers are contained in the complex numbers. Notice that when we write a complex number in binomial form, we have that plus symbol is not the typical sum of real numbers. It is simply a way of separating what is the real part from the imaginary part. An important property in complex numbers. Two complex numbers are equal only if the real part of one is equal to the real part of the other, and the imaginary part of one is equal to the imaginary part of the other. This property is important, and we will use it later when calculating the opposite numbers and the inverse numbers of complex numbers. We continue with two complex numbers. Suppose we have z1, a plus bi, and z2 equals c plus di. Keep in mind that a and b and c and d are numbers that you will know in principle. Here we try to explain everything in a general way, but then you will see some concrete example. The sum is defined like this. z1 plus z2 would be simply, if we read exactly what it says there, a plus c plus b plus d times I. But what does this mean? Actually, how do you add complex numbers? All you have to do is add the real part to the real part of the second complex number and the imaginary part of the first complex number to the imaginary part of the second complex number. What properties does the sum have? The typical ones that we actually expect it to fulfill, for example, the commutative property that simply says that the order in which we add does not alter the result, the associative property, which tells us that if we add three complex numbers, it is the same to start with. Z, 2 plus z, 3, as it is to start with z, 1 plus z, 2, the result in the end is the same. There is also what we call the neutral element. In this case, the neutral element is denoted by 0, but you have to keep in mind that it is the complex number 0, 0 plus 0 times I. So that any complex number added with that stays exactly the same. 0 plus z is always equal to z. There should also be an opposite for the sum. That is, for each complex number z equals a plus bi, there should be an element in a complex number so that adding it gives us the neutral element. In this case, it is very simple to calculate. If we have that z is equal to a plus b times I, the opposite would simply be to change the sign of the real part and the imaginary part. How do we define then the subtraction of complex numbers? It is very simple. we actually rely on addition and the definition of the opposite number of a complex number. For example, if I wanted to subtract z1 minus z2, what I actually do is to add to z1 the opposite of z2. Let's see examples of how this would be done with numbers so we see it clearly. If z1 is equal to 3 minus 2i and z2 is equal to 1 plus 4i, for example, then the sum would simply consist of adding the real part of z1 with the real part of z2. That is the 3 plus the 1 that would give us 4, as the result shows. If we also want to add the imaginary part, notice that in the first complex the imaginary part is minus 2, and in the second one the imaginary part is 4. Therefore the sum would be minus 2 plus 4, which is simply 2. Solution of the sum, 4 plus 2 times I. How would we subtract? I have taken the same numbers, z1 is equal to 3 minus 2i, and z2 is equal to 1 plus 4i. Because it is subtracted in the same way, what we are going to do is actually to calculate the opposite of z2, which, as you can see on the screen, would simply be to change the sign to 1 and 4. That is to say, the opposite of z2 would be minus 1 minus 4, and add the z1. In this case, we add 3 plus minus 1 because we have changed the sign of z2, and to minus 2 we add minus 4. It is easy to verify that the sum would be 2 minus 6 times I. Well, up to here, we have seen the quick introduction to complex numbers and the definition of the sum of complex numbers. What should be clear to us at this point? Well, the definition of complex numbers, the definition of the sum of complex numbers, and the properties that complex numbers have, which are in principle the same properties that real numbers can have. Thank you.